Welcome to the Bone Reconstruction Planner tutorial, which is a 3D slicer extension for virtual surgical planning of mandibular reconstruction with vascularized fibula-free flap and generation of 3D printable patient-specific surgical and resection guides. In this video, I will show you how to download and install 3D slicer and bone reconstruction planner, as well as basic data loading methods and fibula and mandible segmentation. Then I'll show you how to use the Bone Reconstruction Planner to plan your mandibular reconstruction and generate 3D print-ready fibula cutting and resection guides. The 3D slicer can be downloaded from the 3D slicer website. The download section contains 3D slicer binary files for both the stable and preview versions. 3D slicer is compatible with Windows, Mac OS, and Linux. To use Bone Reconstruction Planner, you must currently use the stable version of the 3D slicer. The GitHub page of the Bone Reconstruction Planner can be found at the link below. Here you can create issues and make a feature request and at the same time contribute to the code and the project. Once the 3D slicer program starts, you can access the extension manager from here or by pressing Ctrl+4. In the extension manager, type Bone Reconstruction Planner to install it. Once you click installation button, it might ask to install additional dependencies and you will need to say yes to that. Once everything is installed, it will be very useful if you install the segment editor extra effect module as well. Once all modules are installed, you can simply restart the program. Then you import your DICOM data by starting the DICOM module. Or if you have it in NRRD format, you can simply drag and drop the data into 3D slicer. It will take some time to load depending on the size of your dataset and the hardware. Next step is to segment fibula and make a fibula model. For that, you go to segment editor and create a new segment. Simplest way to segment the fibula is by simple thresholding. Even though more advanced and better alternatives like grow from seed options are available in 3D slicer, this will be good enough in this scenario. Even in simple thresholding method, there are a number of tools like number of automatic thresholding algorithms and histograms for you to select the optimal threshold value for a given structure. In this case, I will simply experiment with the slider to decide on the best value for this CT. To see how well the structures were segmented, you can look at it on the slice views or enable 3D view. You can have a look at the segmentation, and if you are unhappy with the results, you can go back and segment it again. Here I will adjust the threshold again so the bone becomes better defined. For ease of navigation, you can center the objects on the 3D view by clicking on this icon. Further, you can customize the 3D viewport by clicking here, which will reveal number of customization options. Now we want to isolate the fibula bone only and get rid of all the extra structures that were segmented. For this, again number of options are available in slicer. But in this case, I will use the island functions. Islands are continuous components of a segment. Once you select this option and select the island you want to keep, in this case the fibula, the slicer will get rid of all the islands that are not connected to the fibula. Now to fill the surface defects, we can either use closing holes options under smoothing functions or use the wrap solidify function. Here I will use the wrap solidify function as it will not only correct the defects but also solidify the segment. If you want to visualize how this works, you can enable save intermediate results under advanced tab. But beware that this will increase the computational time. Now it is done. Next, we will segment the mandible. For this, create another segmentation named Mandible. Naming the segments properly will help you to keep track of what's what. You can select the CT volume with Mandible and adjust your slice view. We will use the same procedure to segment the mandible. Again, you will need to experiment with the threshold values. You can enable 3D view to see the segments. So if you are not happy with the segments, either you can remove the segment or you can undo it by pressing the Ctrl C. And generally, most steps of the segment editor can be undone with Ctrl C. And you can adjust the threshold again. Now we need to isolate the mandible, and for that we will use the island function. But unlike in the fibula segmentation, here the most of the bone that was segmented are in continuation with each other. Therefore, we need to see where the connections are and manually erase the connections. After that, if you want, you can further edit the segment and get rid of the artifacts with scissor tools. So here you can see the connection and we will erase it. You can erase it in slice view or in 3D view. So now we have successfully isolated the mandible. Like in fibula, now we want to close the holes and solidify the mandible. After you are done, before we use the wrap solidify module in the mandible, since it is a curved structure, we need to separate the mandible into two halves. We create another segment for that and change the settings so we will fill only inside the segment selected and also override it. This will basically create two segments of the mandible. So now you can use the wrap solidify module on each of the segments separately. We repeat the process. Then we again combine the two segments by going to logical operators and adding the two segments together. Then we can get rid of the other segment. Ready to go to Bone Reconstruction Planner. So you go to Find Module and type in the name of the module. Here the first step is to make the fibula and mandibular models using the segments. In the event you are using the right fibula, you need to tick this. Now you click Create Models. But before that, I would like to organize my data and get rid of all the unnecessary data that was saved as a result of using the wrap solidify module. So going back, I create the models. And now the module will create the models and we will get a custom viewport. Before that, I like to go to the data module and hide the segments as we don't need it. Also, I prefer to reformat the red slice view so it is more or less parallel to the lower border of the mandible. There are a number of ways to do this, but the way I prefer to do this is by enabling slice intersections and using shortcut keys Ctrl plus Alt and dragging the mouse with left mouse button pressed in the green and yellow slice views. You can use this to reformat any slice. So once I am satisfied, I can go back to the Bone Reconstruction Planner. Next step is to define the mandibular curve. You can do that in 3D view by default, but if you wish to do it in the slice view, you need to go to the markups modules and enable red slice view. Next, we need to define the fibula line. The direction you draw the fibula line will determine the position of the first and the last osteotomy cuts. Also, you can either draw the line leaving enough bone for ankle stability, or you can mark the full length and then define the space you would like to leave from the distal end. Here I will just draw the line leaving enough bone length at distal end for ankle stability. Then you need to center this fibula line. Next step is to add the cutting planes. You can use the automatic plane positioning option, so the optimal bone contact will be calculated by the program, or you can do it manually. For the best results, we recommend enabling all mandibular planes rotations as well. Once it is done, you can visualize the planned reconstruction. If you want to adjust the display properties of the lines, you can simply go to Markups module and adjust the display properties to suit your needs. Coming back to the slice view, you can see how the bone segments are placed in better detail. Also, you can adjust the display properties to suit your needs again. You can also create 3D models of the virtual surgical plan for 3D printing by clicking this button. If you are not satisfied with the outcome, you can always adjust the planes and the results will be updated in real time. Also, this will display the segment length so the surgeon can be sure that no segment will be too small. Further, the surgeon can adjust the amount of the space between the segments and also leave a security margin so the bone segments will not overlap with each other. The surgeon can change these settings to their personal preferences and finalize the plan. Once virtual surgical plan is completed, next step is the generation of the fibula guide base. So we move to this fibula surgical guide generation settings. Here you can adjust the meter box settings. First steps here is to draw a line telling the program the direction of the meter boxes. The surgeon can place the meter box in anterior or lateral position. I prefer the lateral approach, and here note the direction you start drawing the line matters. You select the line you want to determine the direction and click the create meter box. If you have start the line from the opposite side, the meter boxes will place on the medial surface. You simply need to redraw the line in opposite direction and select the new line and repeat the process. The same principle can be applied if anterior approach is preferred. If you want, you can adjust any parameter for the meter boxes and update it with new parameters. Once you are satisfied with the placement of the meter boxes, next step is the creation of the surgical guide base. For that, we need to go back to the segment editor. Before we go there, we need to unhide the segments that we hid. Once in the segment editor, you can duplicate the fibula segment using logical operators. Then we use hollow effect to create a shell from the newly created segment with inside surface selected, so the guide base will fit to the fibula outer surface. The thickness you put here for the shell will be the thickness of the guide base. Now it is a matter of editing this segment to the surgeon's preference, and I recommend to practice with the segment editor. In editing the fibula guide base, it is easier if the red slice is reformatted perpendicular to the fibula in the same way using the slice intersections. Once you are satisfied with the base, you can smooth the guide base. For that, you can use joint smoothing option as it will preserve the fit of the surgical guide base and the fibula bone. Once you are satisfied with the guide base, you go back to the bone reconstruction module and make sure that the meter boxes are in contact with the guide base. If needed, you adjust the position of the meter boxes. Once everything is in order, you go back to the segment editor and export the guide base as a model. Next step is to place the screw holes to fix the fibula surgical guide to the fibula. For that, you place fiducials in places you wish to fix the surgical guide. Once satisfactory placement of the screw holes are done, we are ready to generate the surgical guide. Once you click this, the surgical guide will be generated, and in order to visualize it, you will need to hide the overlapping models. Then you can save the scene and the surgical guide by clicking the save button. The next step is the mandibular cutting guide generation. For this, you first create the mandibular saw boxes. These saw boxes can be adjusted manually. Once the saw boxes are satisfactory, we need to create a bridge between the two saw boxes. For that, it is easier if we reformat the red slice view with slice intersections and shortcut keys. Once it is done, you can switch to 3D view only to make the bridge. For this, you switch to the markups to model module. You can make the saw boxes visible in the slice view and then start placing the fiducials. It is best to place the fiducials in the slice view so the tumor can be visualized and you can avoid the bridge from being near the tumor. There are many settings in this module as well, and you can play around until you have a satisfactory result. Once it is completed, you go back to the Bone Reconstruction Planner. First, you make a copy of the mandible segmentation to be used as the surgical guide base. Make sure the segmentations are not set to override each other and apply copy segment. Then go to the hollow effect and start marking the mandibular surgical base. Again, the thickness you put here will be the thickness of the base. Now you need to use your imagination and design the guide base. Once you are satisfied with the design, you can use joint smoothing to smoothen the surface while preserving the watertight seal between the guide base and the mandible. Then you can add another segment to create the second part of the surgical guide base. Again, you copy the original mandible segment and start working on the second part. When you are using the joint smoothing, make sure that you hide all other segments that you do not want the smoothing functions to apply, since this is applied to all visible segments. Next step is to join these two segments using logical operators. Then you can export this as the model base. Then returning back to the Bone Reconstruction Planner, we can generate the mandibular resection guide. First, you need to specify where the screw holes to fix the mandibular resection guides are placed. And here, by adjusting the diameter, we can specify the size of the screw holes. If you are not satisfied with any of the settings, you can again adjust before you generate the cutting guide. To visualize your new cutting guide, you can change the color of it and hide the other components. Then you can save the cutting guide in STL or any other format ready for 3D print, and also make sure you save the project. In order to see the surgical cutting guide base properly, I have loaded only the surgical cutting guides. Also, I will show you how to manipulate the 3D objects in 3D Slicer interactively by creating linear transformations. You right click and create a linear transformation and then enable interaction in 3D view. With shift and left click, you can drag the object and simply left click and moving, you will rotate the object. Then once you finish moving the object, you can simply apply the same transformation to the fibula so it will move to the correct position. So this is the final product. All of these are 3D printable.